Hello, in this tutorial we're going to take a look at how to use the inlay toolpath strategy when we need to machine parts that need to fit together accurately. If we take a look at this quick example here, we've got a letter E. Let's say for example we needed to machine a pocket on the left hand side of the E, and then we're going to profile machine around the outer edge of the E on the right hand side. Now in practice these would probably be cut out of two different materials. You'd probably cut the female pocket out of the base material and then cut the letter E out of another piece of material, probably a different color or a different type of material, and then take the one on the right and drop it into the pocket on the left. Now that sounds very simple and very straightforward, but in practice it's actually quite difficult. If we take a look in our three-dimensional view here, if we zoom in, on the left hand side we have the pocket. So we've machined a pocket using, here we've used a 1/2 inch end mill. And you'll see that in the corners, so these corners here, the radius of the cutter is left in the pocket. It's impossible to machine a square corner using a rotating cutter. Where the cutters, it's formed a radius in the corners. Where the cutters come along this edge and down around this corner, it's possible to form a sharp corner. The same on this corner here, it can machine a sharp corner, but then again on the internal corner, we've got the radius of the cutter. So when machining the pocket, we're always going to get these radiuses on the external corners. Then when we go on to machine the male inlay, so we're going to cut this part out of a different piece of material, and the cutter's going to run around the outer edge of the letter E to form the shape, probably cutting all the way through the material. Now again, where we've got an external corner here, the cutter can run along and form a sharp corner. In the top right hand corner here, it can run along this edge and down the front of the E and form two sharp corners. But these sharp corners aren't going to fit into this female pocket because of the radius. But then when the cutter comes round to the internal radius, you'll see here on the E on the right hand side that we've got the radius of the cutter again. If we look at the pocket, because of the nature of the cutting, we're able to form a sharp corner here. So if we pick this piece up and try to slot it into the hole on the left, the two pieces aren't going to fit together. That's why it's important to use what we call the inlay toolpath strategy. If we just pin this open for a moment, you'll see that the inlay options are available from the toolpath operations menu. There's a number of different inlay options, but something to point out before we start is that you must always use the same size cutter to machine the female pocket as you do to machine around to create the male insert or inlay. If you don't use the same cutters, then you'll end up with the wrong radius in each corner. Let's take a closer look at how to create inlay toolpaths. Let's just reset this preview. So reset the preview, go back to a solid. We just split the view, so I'm going to say view tile horizontally so we can see the letter E's in the top and the three-dimensional view in the bottom window. So we're going to machine the female pocket on the left hand side here. So we'll open the inlay machining toolpath form. So we're going to say machine the female inlay, which is the pocket typically. We're going to say we're going to create a pocket. Let's cut this pocket 1/4 inch deep into our 1/2 inch thick material, and we're going to use, for this case, we're going to use a 1/2 inch end mill. In practice, you'd probably use a smaller end mill. The smaller the radius, the better, because then you don't get a radius being formed on the lettering or the logo that you're cutting. But to help to emphasize the effect of the radius of the cutter, we'll use quite a large tool here. So 1/2 inch end mill. So we're going to cut 1/4 inch deep with this tool, and we're going to use offset machining. Now if we say calculate, the software has automatically calculated the toolpath for us. Open the preview window, so I'm going to say preview this toolpath. Let's give this some fill color to make it a little bit easier to see what we're looking at. If we zoom in now, you'll see that we've cut 1/4 inch deep. A little tip here is, you'll notice as I'm placing the cursor in the three-dimensional window, in the bottom right hand corner, you'll see the X, the Y and the Z information being displayed. So here you'll see that I'm X 3.78 inches, Y, we're looking down in this region here, so X, Y, and it's showing me a Z depth of 1/4 of an inch, which is correct. Okay, so we've machined the female pocket, and you'll see that we've formed a radius in each corner here. If we go back and switch the toolpath preview on, now the toolpath preview looks okay, but if we switch on the solid preview, you'll see now if we zoom into this top right hand corner, you'll see that we've got because of the 1/2 inch radius of the cutter that we're using, we're not being able to machine right into the corner, so we have this radius, and that's what we're seeing in the 3-dimensional view. So if we zoom back out, so F to zoom to fit again. Let's switch the solid and the wireframe off for a moment. Now if we were to machine the male insert, so we're going to cut all the way around the outer edge of this letter E. If we say close the form, close preview, let's go back to the inlay toolpath form. This time we're going to cut the male inlay, so we're going to machine this all the way through, so straight all the way through the 1/2 inch thick material. We need to make sure that we're using the same diameter cutter again, so we'll use the 1/2 inch end mill and calculate the toolpath. The toolpath appears in the 3-dimensional view. If we preview the results, so preview this toolpath, you'll see that we've done 2 passes, so that we've profiled machined 2 passes at 1/4 of an inch each level to get 1/2 inch deep. Again, everything looks fine. If we switch the toolpath on, so we can preview the toolpath, show the toolpath in the 2-dimensional view, you'll see that in the 2-dimensional view everything looks correct. The toolpath is going around the outer edge of the letter E. But something that you can't notice very easily is the fact that the inlay toolpath is actually rounding off the corners. So what the toolpath has done is automatically rounded the edges, the external corners on the letter E. So if we switch this to be solid view and we zoom into the top right hand corner again, you'll see that this profile toolpath is cutting around the outer edge of the E, but it's adding a radius around the corner, so it's chopping off this corner portion of the external corners. Now this is very important, as we've just been discussing, because if we look at this corner here, what that does is it allows the 2 pieces to fit together. So again, looking in the 3-dimensional view, let's double click to maximize. We've got the radius here being formed by the male inlay, and that's going to match the radius and the pocket. So if we took these 2 parts, so we took this letter E on the right hand side, took it out of the material because it's been cut free, it would drop into that pocket. Now we say it would drop into the pocket, but at the moment we're cutting exactly, if we say tile view horizontal again, we're cutting exactly to the boundaries of the vectors. So we're cutting exactly to the edge of the letter E in the pocket, and we're cutting exactly around the outer edge of the letter E on the right hand side for the male inlay. Now that would give us 2 parts that were really identical sizes, and you probably wouldn't get them to fit together unless you used a mallet or you were able to clamp them together. In practice, you really need to add an allowance to the toolpath. In most cases, the allowance would be machined into the female pocket. So you would machine the pocket very slightly bigger to allow the male inlay to drop into that pocket. Now the size of the allowance is very dependent on the materials that you're cutting, the precision of your machine, also whether you need to apply glue. For example, if we were going to take this E and drop the 2 together and then glue it in place, you definitely need a gap to allow for some glue to hold the 2 parts in place. So to do that, if we go back and machine the inlay pocket, so we'll say double click to edit the toolpath. On the female inlay, so female inlay pocket toolpath, we're going to leave the depth exactly the same cutting strategy, the same size cutter, but on the form there's a very important field that we need to fill in. Here we have the pocket allowance. Now if you're cutting very small components, then you may only need an allowance of maybe 5 or 10 thousandths. If they're very large letters, you probably need a bigger allowance. this case, these letters are actually 12 inches high, so I'm going to use an allowance here of say 30 thousandths, so 0.030, and this will help us see the result in the two-dimensional view. So if we say recalculate the toolpath on the right hand side here looks almost exactly the same. It's very difficult to see whether there's been any noticeable change. If we say preview the toolpath, you'll see that it's very, very slightly bigger, but it was difficult to see that. If we go back to the two-dimensional view, preview the toolpath, if we zoom in, you'll see now we have the blue line there for the vector boundary, but you'll see the light blue or pale blue that represents the material cut by the 1/2 inch diameter end mill is now cutting slightly bigger than the selected vector for the letter E. This is going to cut us a pocket that's 30 thousandths bigger all round, that will then allow the male insert to drop into that pocket. So just to go through that again, so pocket, specify an allowance. If we make it bigger, for example, let's say we've got a 60 thousandths allowance, recalculate, you'll see that it's overcutting. So in the two-dimensional view, zoom out a little bit, the software has calculated the toolpath that's machining a pocket 60 thousandths bigger all the way around. As I say, the allowance is fairly dependent on the materials and the precision of your machine. There is another, there are some alternative inlay options. Let's just delete the toolpaths that we've got here. So if we say delete toolpath, reset the preview for a moment. So reset preview. If we work with the letter E on the left hand side here, go back to the inlay toolpath form. Let's say we wish to machine a stepped male inlay. So stepped, we're going to cut all the way through the material. We're going to use the same 1/2 inch end mill, but this time we need to specify a depth for a shoulder. So let's say we're going to cut to a depth of say 0.25 of an inch, so 1/4 of an inch deep, and we want to overcut around the outer edge by, let's say, 0.3 of an inch. So now if we say calculate the toolpath looks very similar. If we maximize the three-dimensional view, toolpath looks very similar there, but it's now a stepped male inlay. So if we preview this toolpath, you'll see the toolpath has created if we switch on the color for a moment, so switch on some color, so dark red, delete the waste material, you'll see now that we've got the top face of the letter E is exactly the same. So this would fit into a pocket that was machined all the way through the material and probably pushed through from the back. But then we've got a shoulder on the back. If we edit the toolpath, you'll see that the shoulder is 0.3 of an inch wide. So the distance between the edge of the E and the shoulder is 0.3 of an inch. So if you cut a pocket into some material all the way through the material, using the 1/2 inch cutter, you could then insert this letter E from the back, and the shoulder would stop the letter from pushing all the way through the material. And you could probably glue this into place, or some customers actually machine a pocket on the reverse of the material that this fits into. So again, just to summarize, using the inlay toolpath option, the software will automatically radius external and internal corners and both the pocket or the female pocket and the male insert inlay to ensure that the parts go together.